In 2023, a 744 billion parameter AI model can run on your laptop thanks to breakthroughs in quantization and efficient inference techniques. AI models have grown exponentially in size, with the largest models now boasting hundreds of billions of parameters. Consider GPT-3, with 175 billion parameters, as a benchmark for understanding these massive models. A model with 744 billion parameters requires immense storage and computational power, often beyond the reach of standard hardware. Running such a large model on a typical laptop poses significant challenges, requiring specialized hardware or cloud resources. The computational load of these models demands not just storage, but also efficient processing capabilities. Despite these challenges, breakthroughs in quantization and efficient inference are making it possible to run these models more efficiently. In recent years, AI model efficiency has taken a significant leap forward thanks to techniques like quantization and the use of sparse matrices. These breakthroughs are crucial in reducing the computational load required by large models. Quantization reduces the precision of numbers used in models, which can significantly decrease the amount of memory and compute needed without drastically affecting accuracy. This makes it possible to run complex models on less powerful hardware. Sparse matrices allow models to ignore zero values, which reduces the number of operations and memory footprint. This technique is especially effective in neural networks where many weights are zero. Tools like GPT-Q are enabling these advancements by providing quantization-aware training. This ensures that the model maintains its accuracy while benefiting from reduced computational demands. These techniques allow AI models to run on hardware with limited resources, such as laptops with only 8 GB of RAM. This democratizes access to powerful AI tools. By reducing the computational load, these advancements also lead to energy savings, making AI more sustainable and accessible to a broader audience. To run a 744B model on your laptop, you need to consider the minimum hardware specifications. This includes processor types, RAM requirements, and GPU capabilities. Even integrated GPUs can be sufficient with the right methods. For processors, a modern multi-core CPU is essential. Ideally, you should aim for at least an Intel i7 or AMD Ryzen 7. These processors offer the necessary performance to handle large AI models efficiently. RAM is another critical component. You need at least 16 GB of RAM to ensure smooth operation without bottlenecks. This allows for efficient data handling and better model performance. While dedicated GPUs are ideal, integrated GPUs can also be used effectively. Techniques like model quantization can enable integrated GPUs to perform surprisingly well with AI workloads. Some specific laptop models have been tested successfully with the 744B model. For example, the MacBook Pro with M1 Pro and the Dell XPS 15 with an Intel i7 and NVIDIA GTX 1650 have shown excellent performance. Choosing the right hardware can significantly affect the performance of AI models on your laptop. Balancing CPU, RAM, and GPU capabilities is key to achieving optimal results. Before diving into AI model quantization, it's essential to set up the software environment correctly. This chapter will guide you through installing Python, PyTorch, and specific libraries needed for model quantization and loading. Let's ensure everything is compatible and optimized. First, you'll need Python 3.8. It's a stable version that works well with PyTorch and other libraries. Make sure to download it from the official Python website and follow the installation instructions for your operating system. Next, install PyTorch version 1.10. This version is known for its robust support for model quantization. You can install it using pip, the Python package manager, by running the command pip install torch i110. For model quantization, you'll need the Torch Vision library, version 0.11. It pairs well with PyTorch 1.10 and offers a suite of tools for handling and transforming image data. Ensure that your environment variables are set correctly to include the paths to Python and the installed libraries. This step is crucial for seamless operation and avoiding path errors. For optimal performance, consider configuring PyTorch to use GPU acceleration if available. This can significantly speed up model processing and is especially beneficial for large models. Finally, verify your installation by running a simple script to check the versions of Python, PyTorch, and TorchVision. This helps ensure everything is set up correctly before proceeding with model quantization. To start with, finding the right model checkpoints is crucial. Sites like Hugging Face offer repositories where you can find large models like the 744 billion parameter model. These platforms are a great resource for AI enthusiasts and developers. Downloading these massive files requires a solid internet connection and ample storage space. The model can take up several hundred gigabytes, so ensure you have enough room on your device. Once downloaded, it's essential to verify the integrity of the files. Use checksum tools to ensure that the files haven't been corrupted during download. Managing storage efficiently is key. You might need to move files to external storage or cloud solutions if your local disk space is limited. After verifying and managing storage, the next step is preparing the files for use. This involves unpacking and organizing them into directories that your software environment can access easily. Proper preparation of these files ensures smooth operation when you begin using the model. This step is crucial to avoid any errors during model execution. Quantizing a model is a key step in optimizing it for local inference. This process involves reducing the precision of the model's parameters, which can significantly improve performance on smaller devices like laptops. Tools like GPTQ allow you to apply quantization effectively. They help in reducing the model size without a substantial loss in accuracy, making it feasible to run complex models on consumer-grade hardware. Quantization trades off some precision for performance. While this might slightly reduce the model's accuracy, the increase in speed and efficiency can be well worth it, especially for local inference. For example, a quantized model can achieve speeds up to 3 times faster on a typical laptop compared to its full precision counterpart. This makes it a viable option for users without high-end hardware. Configurations tested on laptops include setting the bit width to 8 bits for waits and activations. This strikes a balance between maintaining model performance and reducing computational load. In practice, users have reported processing speeds of up to 180 tokens per second on a mid-range laptop, which is sufficient for many local applications. Ultimately, quantization is a powerful tool for bringing high-performance AI models to consumer devices, making advanced applications more accessible to everyday users. Once you've quantized your model, the next step is to run it locally on your laptop. This chapter will guide you through executing the quantized model, ensuring you can utilize it effectively without relying on a cloud service. First, open your command line interface and navigate to the directory containing your quantized model files. Use the command python run model.py to initiate the process. Ensure your environment variables are correctly set up to avoid any path issues. If you encounter a memory overflow error, consider reducing the batch size or upgrading your RAM. A common command adjustment is setting the batch size to 1 by modifying the script to python run model.py, batch size 1. Slow inference speeds can often be improved by optimizing your model's configuration. Ensure you are using multi-threading by setting the cluster's threads parameter to match your CPU's core count. A well-optimized quantized model should achieve around 180 tokens per second on a mid-range laptop. If your performance significantly deviates from this, revisit your setup and configuration files for potential improvements. Remember, every setup is unique, and troubleshooting might involve a few iterations. Keep a log of changes to track what improves performance and what doesn't. Running your model locally allows for greater control and privacy. However, it demands attention to hardware specifications and configurations to ensure smooth operation. Optimizing performance in AI models involves techniques like model pruning, which effectively reduces the model size by removing unnecessary parameters without significantly impacting accuracy. Model pruning can lead to a reduction of up to 90% in model size, which translates to faster inference times and reduced memory usage. Another optimization technique is using lower precision data types like INT8, which can speed up computation by up to 3 to 4 times, though it may slightly affect accuracy. In real-world scenarios, using INT8 precision can lead to a slight drop in accuracy of about 1 to 2%, which is often an acceptable trade-off for the performance gain. Comparing pruned models with their full-sized counterparts the pruned models can achieve similar performance while using significantly less computational resources. Testing on specific benchmarks like ResNet 50, pruned models showed a performance improvement of up to 50% while maintaining accuracy within acceptable limits. Overall, selecting the right optimization technique depends on the specific use case and the acceptable balance between performance and accuracy. Running a large AI model locally opens up a world of possibilities for personal projects, like creating AI-enhanced music or art. It allows for offline data analysis, which can be crucial for privacy-sensitive applications. However, there are limitations to consider. Quantization can reduce model accuracy, which might not be ideal for complex tasks requiring high precision. For tasks that demand high accuracy, like medical imaging or scientific research, running a quantized model locally might not meet the necessary standards. On the flip side, for creative projects that don't require pinpoint accuracy, local execution can be a powerful tool. Imagine composing music with AI-generated melodies or creating digital art with style transfer. It's important to evaluate whether local execution aligns with your project's goals. If the task requires constant updates or large-scale processing, cloud-based solutions may be more appropriate. Offline data analysis is another strong use case for local execution, especially in fields requiring data confidentiality, like finance or healthcare. Ultimately, the decision to run a model locally should be based on your specific needs, balancing performance with convenience. For running a 744 billion parameter model on your laptop, start with a quantization tool like GPT-Q to reduce computational demands, and ensure your laptop has at least 8 GB of RAM. Throughout this video, we've explored the importance of understanding AI model sizes, setting up the right hardware, and optimizing performance. Start with a quantization tool like GPT-Q for the best balance of feasibility and performance when running large models locally.